Morning, Year 11. In this review, we're going to look at the bubble sort algorithm. We're going to go through a bubble sort, we're going to look at the pseudocode and finish with the answers for the homework. It's very important that you grasp the concept of sorting and the efficiencies of sorting algorithms in computer science. So we'll begin looking at the animation or the video from our OneNote, which takes us through a complete bubble sort when we're iterating the length of the array, and within an inner pass we're checking that the elements are in their proper position. So take time to watch this and then we will look at the pseudocode.
Done with the first iteration. 9 is now in the correct spot. Let's continue. You get the picture. I'll see you at the end of the algorithm. We're done. Our array is sorted. Here's the pseudocode for bubble sort.
So we pick it up here looking at the pseudocode. You should be able to recognize the bubble sort algorithm from its pseudocode. And the first thing that you're looking for is a nested iteration. That's 2 loops. You can see that there's an outer loop here for I in range 1 to n. That's going to be the length of the array. You see there's an inner loop for j in range 0 to the length of the array -1. Then you will notice there's the comparison and then a swap operation. Although this is pseudocode, it's saying there's a direct swap here. In reality, you would need a temporary variable to hold one of the values to allow you to swap. But note, outer loop, inner loop, a comparison and a swap. And that's the giveaways of a bubble sort. So let's look at it with regards our homework questions. And I'm going to go through just question 5a. If you want to check your answers, pause now, all the answers on screen. I'm going to work through the mechanics of the bubble sort. So what we have here in question 5a, you were asked to show the first pass. So I'm going to write out the state of the array. The unsorted array was 5, 2, 1, 3 and 4. And I'm now going to do the first pass. The comparison with 5 and 2, 5 is greater than 2, so we have 2, 5, 1, 3 and 4. That's after the first operation. We're still in the first pass because if you remember, we have to compare each value. We're now in our inner loop, so comparing 5 with 1, so it's going to be 2, 1, 5, 3, 4. And I'll just place a dot over the 5 because that's where I'm in now. In my inner loop, I'm going to be comparing 5 with 3, and 5 is greater than 3. It's going to be 2, 1, 3, 5 and 4. I'm still in my inner loop and I'm making a comparison with 5 and 4. So at the end of the first pass, it's 2, 1, 3, 4, 5, and my first pass is complete. I'm now back to the outer loop to look at, start at the search from 1 less than the length of the array. So we know that 5 is bubbled up into position. Our next inner pass should only have 4 iterations because we know that the first element has been sorted. So you can see there's your answers for the first pass, ending 2, 1, 3, 4, 5, which is 2, 1, 3, 4, 5. So we now look at our second pass, and again you were asked to complete the second pass. So the second fast is going to begin with comparing 1 with 2, and 1 is greater than 2, so I've got 1, 2 is swapped, 3, 4 and 5, and although that array is sorted, the algorithm doesn't know that it's sorted because we're only in the second pass of our inner loop. You can note I've put the dot against 2, so it's going to compare 2 with 3 and it's going to realise there's no swap, but it still has to continue with the algorithm. It's now going to compare 3 with 4, and again there'll be no swap, and we already know that 5 is sorted, so we can break out of the array there. Some algorithms will not take that into account and will do the final pass, and you have 1, 2, 3, 4, 5. Now there is one way around this. Often bubble sort will have a variable called swap in it, and if you make a complete pass, one full pass without a swap, we could flip that flag to false and we could break out of our inner iteration. So there is a way that we can make it slightly more efficient, that if you realize in one entire pass, if you went through the array and made no swaps, we know it must be sorted, therefore we could break out of it. And that gives us our answer to the last question. So you'll see here that although it's sorted, it goes through a number of passes. You're also asked too about the efficiency of the bubble sort algorithm. We know that it's inefficient, but you should be able to explain why it's inefficient, and it's inefficient because of the nested iteration. In this case here, we've got 5 elements in the array. That's 5 passes of an outer loop multiplied by 5 passes in an inner loop, worst case scenario if we don't have a flag to break out of it, and that equals 25 operations. We call this an n squared algorithm, n being the number of elements in the data set. So if we've got 10, that will evaluate to a possible 100 operations at worst case scenario. So again, final chance, you can pause the video, you can look at your answers, make sure that you're sure of where you've went wrong, and we meet again the Monday after midterm, folks. Have a great break, and we'll speak again Monday week.